Have you ever had a dream like that makes you unable to tell if it's a dream or in reality? This is a topic I've wanted to talk about for a long time after consulting a lot of scientific content. Sorted out today's video. Are we real after all? Or what is real? For scientists, if an object's properties are determined before being measured, then it is real. For example, even if you don't look at it, the apple is still on the table. However, the quantum world seems follows a completely different law. 2022, 3 scientists for proving that our universe won the Nobel Prize for being not locally real. But if our world is not real, then what exactly is this world? Let's start with an incredible experiment. Imagine you and I are at opposite ends of the solar system. 2 coins were thrown from the center of the solar system to you respectively. When the coins are flying in space, they are constantly spinning. According to quantum mechanics, we cannot predict which side the coin will land on. In the end, the result is random. But when you measure that his coin is heads up, you can instantly know my coin must be tails up. Even if 200 consecutive predictions are accurate. If this is purely random coincidence, the probability of it happening is unbelievably small. About 1 in 10 to the 60th power. This number more than the total number of atoms in the entire solar system. Even though you and I are billions of kilometers apart, quantum mechanics suggests you can predict my side's results accurately based on what you measure. It's like between these 2 coins. There is some kind of telepathic connection. This thought experiment is called Einstein, Podolsky, Rosen. Meow, this sounds incredible. However, that's how the universe works. This kind of beyond distance synchronicity. How does the connection happen? Does it mean some kind of information can travel faster than light, thus subverting our basic understanding of the universe? What exactly are the pixels of our reality? And how does the universe go from a predictable state to a random state? Before the advent of quantum mechanics, scientists generally believed the world was deterministic. They thought that as long as you grasped certain specific properties of a physical system, you could deduce all states of that system in the past and future. But then, physicists discovered a phenomenon called quantum entanglement. It describes a state where 2 instances, no matter how far apart, can maintain a mysterious connection. That might not sound so amazing, but imagine that even if this pair of entangled instances is located at opposite ends of the universe, this connection is still valid. That seems a bit strange. Even in the world of quantum mechanics, we usually think that the speed of any matter's movement cannot exceed the speed of light. This means that there is an upper limit to the speed at which any signal can be transmitted. However, if you create a pair of entangled instances and launch them in opposite directions, constantly increasing the distance between them, and then measure the quantum state of one of the instances, the quantum state of the other instance will be instantly determined. For example, suppose there are 2 boxes, each containing a white or a black stone. So whenever and wherever, as long as someone opens one of the boxes, they can immediately know the color of the stone in the other box. This phenomenon has been verified over hundreds of kilometers. Its response speed, if this kind of correlation is propagated through some hidden signal. The lower limit of the propagation speed of the signal far exceeds the speed of light. But although this correlation appears to be instantaneous, even far beyond the signal propagation that the speed of light can explain, physicists generally believe that this cannot be used to transmit classical, meaningful information, thereby violating the theory of relativity. The determination of a measurement result at one location does not allow a person at another remote location to know exactly what the result is without classical communication tools. But that's not all. Just like we measure our weight, scientists discover the properties of particles through measurement. But what if these properties are only determined the moment you measure them? This means that our universe cannot simultaneously satisfy the 2 premises of locality and realism. At least one of them is wrong, or even both. Defining reality is tricky. We can't see tiny particles, but they do exist. We can't touch the air, but it is indeed the So what exactly is reality? Let's go deeper. In physics, reality means that objects always have definite properties, regardless of whether we are measuring them or not. In other words, a fallen tree in the forest does make a sound even if no one is there to hear it, and locality means that objects can only be affected by their surrounding environment, and The propagation speed of this influence cannot exceed the speed of light. It is important that we perceive the world as real, because, as Isaac Newton believed, if you know the position of all the components that make up our world, and speed and determine the forces that affect them, then physics can predict. The state of the world at any moment in the future. However, the quantum world often exhibits uncertainty. Simply put, it is often random or unpredictable, like the famous double-slit experiment. It is even called the most terrifying physical experiment in the world by some because it profoundly shakes our understanding of reality. In 1807, British physicist Thomas Young passed the double-slit experiment. Let a beam of light pass through two narrow slits on the baffle. If light is a particle, two clear bright lines should appear on the screen. If light is a wave, it will interfere, form zebra-like alternating light and dark stripes. The experimental result is the appearance of wave interference fringes. However, after the rise of quantum mechanics in the 20th century, the strangeness of this experiment, the essence, is truly revealed. Scientists upgraded the experiment. Try to emit only one photon at a time logically. A single photon can only pass through one slit at a time, cannot interfere with itself or other photons. There should only be two bright lines left on the screen. But shockingly, as the number of photons accumulates, dry fringes reappeared on the screen. How does a single photon know the other one? The existence of the seam, and with whom did the interference occur? This question has become a problem that plagues physicists. In order to solve this mystery, physicists installed probes at the slits trying to peek at which slit the photon passed through. But what happened next? The entire physics community was shaken by it. Once the detector is turned on to observe the path of the photon, the interference fringes on the screen disappear immediately. Only two bright lines remain that conform to particle behavior. And once the detector is turned off and the observation is stopped, interference fringes reappear miraculously. It's as if the photon has some kind of consciousness, able to perceive whether they are being observed, and decide whether to pass in the form of a wave or in the form of particles. This phenomenon, the act of observing itself, actually changed the experimental results. Means the behavior of microscopic particles does not exist independently of the observer. This phenomenon of observation changing experimental results directly challenges the concept of authenticity. The Copenhagen interpretation of quantum mechanics believes that before being observed, microscopic particles are in a superposition of multiple possibilities, until the act of observation causes its wave function to collapse. The particle will exhibit a definite form. In order to further explore the mysteries of the quantum world, scientists have even designed more sophisticated delayed choice experiment. That is, after the photon has passed through the double slit, then decide whether to conduct path observation. The results are still puzzling. Future observation behavior seems to be able to influence the way photons passed through the double slit in the past, when the behavior, the law of causality of time, becomes less absolute in the quantum world. What's more, the quantum eraser experiment shows that if after the photon passes through the double slit, erase its path information through quantum entanglement and other technologies, that is to let observers cannot know which path the photon took, then even if path detection has been performed before, interference fringes can be restored. This seems to imply that it's not just the act of observing, but the existence or absence of information itself determines the behavior of examples. So when we say some aspects of quantum physics looks completely random or scary, largely stems from the double slit experiment. Revealed this subversive cognition, the world we observe. Its state seems to be not already determined before we observed it, but affected by observation behavior and even the profound influence of the presence or absence of information. This makes people wonder, what is the essence of reality, what we see? Is it just the result we choose to see? As Bohr said, before the observation happens, no physical quantity is objective. This subversion of cognition triggered a discussion about reality, a deep philosophical reflection on the essence. Einstein was deeply disturbed by this. He believes that quantum mechanics is not complete and believe that there are undiscovered hidden variables determining the behavior of particles behind. However, John Clauser, Alan Aspect and Anton Zeilinger, these three scientists won the Nobel Prize for proving that these citations do not exist. The scientists concluded that an entangled example, before being measured, does not have any definite attributes. Therefore, these attributes cannot be obtained in any way before warned or guess new reality theories when physics and quantum mechanics It is also difficult to figure out the true nature. Exploratory new theories emerge if the universe not as real as we traditionally think everything we see and experience. What exactly is it? Some physicists have proposed a new reality theory. It is believed that the basic structure of the universe may not continuous but like a display consists of discrete pixels. For example, some scientists have proposed in theoretical exploration the basic building block of the universe may be a geometry called tetrahedron. Structure. Its side length is the theoretically smallest unit of length, Planck length. Each such cosmic pixel can only be in a limited number of states, and the state of one pixel will affect and determine the state of other pixels, thus weaving the reality of the entire universe. These are hypotheses at the forefront of physics, only in explaining some deep-seated problems, but has not been experimentally confirmed. If reality, at its most fundamental level, it is composed of information, the generation of information and meaning requires comparison and selection, which suggests consciousness plays a role in the construction of reality. Just as we can only know the properties of entangled particles by measuring them, does meaning or information exist only when perceived or measured? These are thought-provoking philosophical questions, and the direction that some cutting-edge physical theories, such as quantum Bayesianism, are trying to explore. But it is far from being a consensus in the scientific community. If that's the case, then reality may indeed be the product of the interaction between consciousness and information. Simulation hypothesis. When existing theories fail to provide satisfactory answers, hypotheses come into play. Regarding our existence, the simulation hypothesis was proposed by Nick Bostrom, a philosopher at Oxford University. Some scientists even believe that the probability of us living in a simulated reality is as high as 50%. This is also a fascinating philosophical conjecture, and a direction for scientific exploration. Then, if we really live in a simulation program, how can we find clues? A key premise is that the computing power of the computer hardware that creates this simulation cannot be infinite. Therefore, theoretically, we may be able to find the truth by looking for loopholes or computational bottlenecks in the simulation program. Therefore, scientists are looking for various ways to try to expose flaws in the simulation program. Through experiments. The idea of these experiments is to overload a theoretical computer with limited computing resources. Meanwhile, other scientists are looking for other evidence. They think all computing hardware will leave traces of its existence inside the simulated reality in which it operates. Therefore, per unit time, there should be an upper limit to the processing speed of operations. Coincidentally, there is such a trace in our universe, which is the speed of light. The speed of light remains constant regardless of the observer. There is an upper limit to the speed of light. This cannot be explained by existing physics. So, we may not know which computer is running our simulated reality, nor do we know what features it has. But one thing is certain. If it performs an operation every second, then the memory container used to store variable space will be about 300,000 kilometers in size. Perhaps the reason we have a speed of light limit is to limit us from arriving there before another galaxy has been programmed into this computer. But this is not the only sign that we may be living in a simulation program. Finally, let's talk about an equally profound and closely related issue of self-awareness. In movies or games, we often use the perspective of the character to show things we watch on the screen and hear from the speakers, but these experiences have no meaning to the character itself. It exists purely for the experience of us, the audience, or the player. If we accept the simulation hypothesis, this thought experiment, then consciousness has a clear purpose. It is composed of 5 senses and integrated subjective interface. The laws of nature and evolution are difficult to perfectly explain the origin and utility of consciousness, such an energy-consuming conscious experience. If it cannot provide a significant survival advantage, then it is likely to serve the existence outside the experiencer. If one day we discover a way to simulate conscious life, then the probability of us living in a simulated reality will skyrocket. Physicists at the University of Maryland are already trying to simulate complex physical systems. From atomic nuclei to molecules, they believe future technology may have the potential to simulate the human brain. If we really live in a simulation, what does our free will mean? Maybe the creators just want to observe how life with free will develops without preset instructions. The long years we experience may just be a blink of an eye for them, after seeing so many physical phenomena and hypotheses. Do you think everything in the universe is determined by our observation? And are we living in a simulation program? Feel free to express your opinions in the comment section.